Chapter 8, Section 1. I love new chapters, new beginnings. Here we go. Inverse and joint variation. If you'll remember, we did direct variation already. And we said that the direct variation, if y varies directly as x, then that means y equals a constant times x. So the inverse variation is going to be y equals a divided by x. So a constant divided by x is the inverse variation. So that makes sense. If you vary directly, you're going to multiply. If you vary inversely, you're going to divide. And the way we read this is y varies inversely as x. This is how we would read that, whereas this is y varies directly as x. All right, so the first thing you're going to need to do is determine whether or not, or whether equations represent direct variation, inverse variation, or neither. And what you'll have to do in order to do that is simply solve for y and then see if they fit one or the other of these equations. So let's just do that on these three. So y minus 3x equals 0. If you add 3x to both sides, then y equals 3x. And y equals 3x is, we've got a constant times x, so this would be an example of direct variation. And that's it. That's all you do on these. So x equals 3 divided by y. So in order to get the y by itself here, you're going to have to multiply by the y on both sides. So then you have y times x equals 3, and then divide by x. So y equals 3 over x. And y equals 3 over x is y equals a over x. So this one is inverse variation. Easy, right? Here we go. Last one of this type. So if we have x plus y equals 5, we got to solve for y. So subtract the x from both sides. So y equals 5 minus x. So which one of those does this fall under? Do we have a constant times x? No, we do not. Do we have a constant divided by x? No, we do not. So in this case, because we're not dealing with multiplication here, this is neither. So these do not vary directly or inversely. All right, so those are the three different types that you will come upon, and so you'll have a section of your homework where you just decide, is this direct variation, inverse variation, or neither? Easy. The next section, the next type of thing we're going to do with inverse variation is we want to write an inverse variation equation and then find y when x equals negative 10. We've done this, we did this with the with direct variation. You know that if it varies inversely, you're going to have a constant that's going to stay the same. That a is going to stay the same in this inverse variation. So what you need to do is, you know that your equation is y equals a over x. And if I give you, I want to know what is the inverse variation equation when y equals 15 and x equals 1/3. If I've given you an x and a y, you can put in the x and the y, and then the a is the only unknown, and you can solve for that. So you put in 15 for y equals a over the x is 1/3. And so now you just solve for a. So if you divide it by 1/3, you can multiply by 1/3. And then make sure to multiply by 1/3 on the other side. And so 15 times 1/3 is the same as 1/3 times 15 over 1. And so that reduces down to 5. So a equals 5. So if a equals 5, then we can put that back into our original equation, and y equals 5 over x is our inverse variation. So that's the first part, is what is the inverse variation equation. So there it is. Find the a and then just put it into the equation. And then find y when x is negative 10. Well, that's easy. You just put in negative 10 for x. So y equals 5 over negative 10. I put in the negative 10. So y equals negative 1/2 when x is negative 10. All right, pretty easy. All right, let's move on then. So if you have a chart of numbers and you want to know, well, do these vary directly or do these vary inversely? You can check for inverse variation actually very simply, because if you look, the formula for inverse variation is y equals a divided by x. If you solve for a and multiply both sides by x, then x, y equals a. So if you have a group of numbers and if you multiply your x and your y together and you get the same number over and over and over, then you know that this is a group of numbers that represent an inverse variation function. So let me show you what I mean. If I've got a moving company and we sell curtains, and the area of those cartons, the area of the base of those cartons is represented by 50, 100, 120, and 150. And the height of each of these respective cartons is 24, 12, 8, and 10. I want to know, so are these moving cartons, is there a variation? Is there a direct or inverse variation involved? And if so, what is that? So first I want to find a model of h as a function of a. So what I can do is I can look and say, well, 50 times 24 is 1,200. 100 times 12 is 1,200. 120 times 10 is 1,200. And 150 times 8 is 40, 12, is 1,200. So when I multiply my x and my y, each time I get 100. So if I multiply and get the same number, that means that I have an inverse variation. So what I can do now is take that information, because now I know what my constant is. My constant is 1,200. And so the a is 1,200. So now to find the model of h as a function of a, so now h, and now h is my height, and this capital A is the area. I'm confusing you now because you've got a little a and a big A. So h is 1,200 divided by the area. So no matter what the height and area are, if I take 1,200 and divide by the area, I'm going to get the height. So now if I want to know, well, what is the height if I know that the area is 75? Well, that's easy. Now you just plug it in. What is the height when I know the area is 75? And I worked that out. What is 1,200 divided by 75? Oh, look, it even comes out evenly. 1,200 divided by 75 is going to be 16, and they said inches squared, so this is 16 inches. All right? Easy sneezy. So if there's an inverse variation, you can check for that variation by multiplying your x and your y terms and getting your constant. If you get a constant every time, then you know, aha, these numbers do vary inversely. All right? Now, the only other thing, if you'll look, I said we were going to do inverse and joint variation. Joint variation, and the reason we're covering two things is because this is so quick and easy and simple. Joint variation is when numbers vary directly with a product of two or more quantities. So this says that z varies directly as x and y. So z varies directly with x and y. So what happens now is the exact same thing as direct variation, except that there's more than one quantity involved. So if z is 60, when x is -4 and y equals 5, and this is true, that z varies directly with x and y, I want to find z when x is 7 and y is 2. So this is the same thing as we've done before with direct variation. It just involves more than one number. It's two numbers. So if z is 60, so there's my equation. If z varies directly with x and y, we're just going to put, if we put in a z, an x, and a y, we'll get out our constant. And if I'm told that it varies jointly, then if it varies jointly, then that means that A is going to be the same every time. So if we find it once, then we know it's true for the other variations as well. So if Z is 60, when X is -4, so A is still unknown, X is -4 and Y is 5. So now we just solve for A. So now -4 times 5 is -20, so 60 equals A times -20. Divide both sides by -20. So A is equal to -3. Yes? 6 divided by 2 is 3. Yes. So A is -3. So now my joint variation is Z varies directly. Z equals -3xy. There's my joint variation, formula. And now, because I have the variation, excuse me, now I want to know, well, what is Z when X is 7 and Y is 2? Well, now you just plug them in. So let's see if Z, what is Z? So Z equals, and now we know A is -3, and they're going to give us X is 7 and Y is 2. And so now we just multiply that to find what Z is. -21 times 2 is 42. Yes, -42. I did that in my head. Yes. I know some of you did it quicker. All right. I think that's pretty simple. So varies jointly simply means you're varying directly, but you've got more than one quantity involved. The only other thing, the last thing now is we're going to be able to, I need you to be able to read a statement and then write that as a variation. And that's what this is. Let me show you. This is what this looks like. And if you think, oh yeah, I've got that, then just pause it and do them real quick. Or just do them as I'm talking and see if you can get ahead of me. That might be even better. So the last section of your homework, you're going to need to take statements like this and then write them in variation format. So the first one says R varies inversely with S. So you'll need to remember that varying inversely is the division. So R varies inversely, so there's your A is always, the A is always going to be your constant. A over S. And that's it, you're done. All right, all I want you to do with this is be able to set up the variation. Okay, do the second one. Z varies jointly with X and the square root of Y. So write exactly what you see. This is almost going back to where we changed word problems into a mathematical equation. So you're just changing the words into letters. All right. So Z varies jointly. So we're going to have more than one. So we've got an A. Varies jointly means we're going to multiply them with X and the square root of Y. So you're just translating word by word. P varies inversely. So the A is on top and you're going to have something on bottom. Varies inversely with the cube of Q. So the cube of Q. Easy sneezy. And then you can have both together. M varies directly with the square root of N. So don't forget the A. Varies directly with the square of N. And inversely with P. So if it says inversely, it's going to be in the denominator, and if it varies directly, then you're going to multiply. All right? So you can have joint variations and inverse variations and direct variations all together. And so you just need to read word by word by word to see, do I put this in the top or the bottom? And don't forget that each one of those is going to have a constant term also. That's part of the variation. All right? Easy, easy, easy day. I think that's all I have for you. Inverse and joint variations, go for it.